Hello, Math140 students. This is your instructor, Cindy Enrique, and we will continue with Chapter 10. We will pick up on page 19, which is section 10.5, Solving Nonlinear Inequalities. So now that we have some practice solving quadratic equations, now we can learn how to solve quadratic inequalities. So for example, it says solve. Write the solution set using interval notation, then graph the solution set on a number line. So if we're talking about interval notation, in case you need a little review, that's where we either have our parentheses, our brackets, or a combination of brackets and parentheses. And you always go from the minimum value to the maximum value for this interval notation. So what we're going to do, the first thing we're going to do, so here are our steps. We're going to make sure that it's set equal to 0. Our original equation. So right now we have x squared minus x is equal to 6. So I'm going to subtract 6 from both sides. So x squared minus x minus 6 is equal to 0. Now it's set to 0. So our second step is we are going to find our critical points, our boundary points. And here, because it's a degree 2 polynomial, see how the exponent is 2, so it is degree 2. We can solve that by hopefully either factoring. That's a good way of solving for it. Another way we can solve for it is the quadratic formula. And the third way we can solve for it is completing the square. But our favorite way to solve for it is by factoring. So let's see if we can factor this. So I know that x times x is x squared. 2 times 3 is equal to 6, and it's a negative 3 and a positive 2. So I'm going to have that x plus 2 is equal to 0. So x is equal to negative 2. X minus 3 is equal to 0. So x is equal to a positive 3. So now we have found our boundary points. So our boundary points is x is equal to negative 2 and x is equal to a positive 3. So the next thing we want to do is graph our boundary points on the number line. So for this step, I'm going to draw my number line. And I have a negative 2 as well as a positive 3. I know at these specific values, this is when the equation is going to be 0. So now I want to see what's going to happen in the intervals. So find positive, negative intervals on the number line. So for example, let's pick a number that lives to the left of negative 2. So we can pick, I don't know, what's less than negative 2? Negative 3, negative 4, negative 5, negative 10, negative 100, negative 1,000,000. So let's just keep it simple. Let's just go with x is equal to a negative 3. So I'm going to plug this negative 3 into my equation. So I have my x squared minus x minus 6. And let's see what we're going to get. So what we're plugging in is a negative 3 into my x, okay? So when I do that, let's see. So I'm going to have a negative 3 squared minus negative 3 minus 6, and I get a positive 6. So that positive 6 tells me that anything over on the left-hand side of negative 2 would be positive. So that means if I had picked negative 4, negative 5, negative 10, negative 100, I still would have gotten a positive answer. So now let's pick something in this interval. What's a number between -2 and 3? You could have picked 2, 1, 0, or -1. Let's just make it easy. Let's go with x is equal to 0. So now I'm going to have x squared minus x minus 6. Let's see what we get. And we're plugging in 0 here. So I'm going to get a -6. So it's a negative in that interval. And now let's go ahead and try our last one. So I don't know. I could pick 4, 5, 6, 7, 8, 10, 100, right? Anything to the right of 3. So let's just keep it easy. Let's keep it x is equal to 4. So I'm going to have x squared minus x minus 6. And that number that I'm plugging in here is 4. So I'm going to have 4 squared, oops, and that's inside parentheses, minus 4 minus 6. And that's going to give me a positive again. So now I have my intervals. So let's look at what I originally had. I had that x squared minus x less than 6. So x squared minus x is minus 6 less than 0. So this is specifically telling us that we want intervals that it's less than 0. So that means that we want negative intervals. So if we want our negative intervals, that's here. This is where it's negative. It's negative between -2 and +3. So because that's true, then I can graph this. So between my -2 and +3, I know my negative interval where it's negative is between -2 and 3. So my interval notation goes between -2 and 3. That's my smallest x value and my maximum x value there. Okay. So hopefully that helps you. That was our first introduction to solving a quadratic inequality. Now let's look at example number 2. At example number 2, this is nice because it's already set to 0. So I'm going to go ahead and find my boundary points. So I'm going to have x squared plus 3x is equal to 0. So I'm going to factor. My GCF here is x. So I'll have an x plus 3 is equal to 0. So I have that x is equal to 0. And I have x plus 3 is equal to 0. So x is equal to -3. So I have my boundary point as x is equal to 0 and x is equal to a -3. So I'm going to graph this on my number line. So I have a -3 and I have a 0. Now I'm going to test these boundary points. So I don't know, let's pick a value over here. So let's choose x is equal to -4. Okay, so I'm going to plug that into my equation. So I have my x squared plus 3 times my x. Let's see what I get when I plug in a -4 into this equation. So -4 squared plus 3 times my -4. And that's going to give me a +4. So in here I have a positive. Now let's pick another number that lives between 0 and -3. So I don't know, -1 or -2 would work. So let's just, I don't know, pick -1. Why not? So I'm going to have x squared plus 3 times x. And let's see what I end up getting. So here I'm plugging in a -1, and let's see what we get. So -1 squared plus 3 times -1, and I get a -2. So that interval is going to be negative. And now I need my last one. So let's pick a number that lives to the right. So I don't know, let's pick x is equal to 1. So I am going to have 1 squared plus 3 times 1. And let's see what happens when we plug that in. So I'm plugging in 1. So if I have 1 squared plus 3 times 1, I end up getting a positive 4. So it's positive. So remember, what we have is we have x squared plus 3x greater than or equal to 0. So that greater than or equal to 0, that's looking for positive intervals since it's bigger than 0, and also includes 0 because there's a line underneath the inequality. So this here tells us that it also includes the 0. So if we're looking for our positive intervals, that's here and here. So when I regraph this, I have my critical values, or sorry, my boundary points. We have -3 and 0. And we are going to have a closed filled-in circle, since there is a line underneath inequality that goes this way, and a closed filled-in closed circle at 0, and it goes off this way. So that's what my graph is going to look like. So once I have the graph, it's a lot easier to write my interval notation. So when I write my interval notation, it's going to go from my smallest values to my biggest values. So in this particular case, it looks like I'm going to have 2 intervals. So I'm going to go from -infinity to -3. Union, and I pick up at 0 since it's a closed filled-in circle. I'm really specifically using brackets here. So make sure that you have your brackets. And then it shoots off to a positive infinity. And positive and negative infinity always have parentheses around it. Okay. So now, of course, we have some practice problems. So this is where you guys are going to try to do it by yourself. I will work them out as well, but you guys are going to press pause and work out these problems. So go ahead and press pause. So I really do hope that you guys worked out these problems. So for number 1, I was able to factor, and I got my boundary points as x is equal to 4 and x is equal to -2. And since it was less than or equal to 0, then I definitely wanted my negative intervals. And so I plugged in values, I found my negative interval, and then I regraphed it and I rewrote it using interval notation from my minimum value to my maximum value. For number 2, for this one, it wasn't equal to 0, so I had to FOIL first that 3x minus 8 squared. So I FOILed that out, and then I added 5 because I had that -5 to begin with. And then I tried to factor it, and I definitely had a 3 that could factor, but then the inside, that 3x squared minus 16x plus 23 did not factor. So because it didn't factor, I used the quadratic formula, which was that -b plus or minus the square root of b squared minus 4ac all over my 2a. So I found my b value and my a value and my c value, and I plugged it in accordingly. But then when I simplified it, it turned out that the inside of the square root was negative. And when that happens, I know that I have non-real solutions, so I could stop. That's as far as I can go with that problem. All right, so now I'm going to have more examples. These are slightly different. So again, I want to solve, and I want to write the solution set using interval notation, then graph the solution set on the number line. And I kind of do it out of order. I solve for it, I graph it, and then I use the interval notation. I usually find that graphing it first makes the interval notation a lot easier. So for number 1, this one's really nice because it's already set to 0. So I can already tell you what my boundary points are going to be. So I have x plus 4 is equal to 0. So x is equal to a negative 4. X plus 1 is equal to 0. So x is equal to a negative 1. And x minus 3 is equal to 0. So x is equal to a positive 3. So now I have 3 different boundary points. So I have a negative 4, a negative 1, and a positive 3 that I'm looking at. So now I'm just going to have some values that I'm plugging in. So remember, I'm going to plug in values into my original equation, which is that x plus 4, x plus 1, and my x minus 3. So over here, I don't know, let's pick x is equal to negative 5. So I'm going to plug in negative 5. So x is equal to a negative 5. Let's see what happens. So the value that I'm plugging in is a negative 5 for my x. And let's see what happens. So I'm going to have a negative 5 plus 4, parentheses negative 5 plus 1, and negative 5 minus 3. When I plug that in all in, I end up getting a negative 32. So there is my negative value, okay? So now over here, let's pick another value. I'm going to choose x is equal to a negative 2. Why not? So I'm going to change this slightly. And now I'm letting it equal to a negative 2 that I'm plugging into my equation. So I'm going to have negative 2 plus 4, negative 2 plus 1, and negative 2 minus 3. And I end up getting a positive number, and it's a positive 10 that I end up getting. So I have a positive number. Okay, now let's pick a different value. Let's say I want something over here. So I don't know, let's try x is equal to 0 now. So if I have x is equal to 0, let's see what I get. So I'll get positive 4 times 1 times a negative 3, and I get a negative 12. So I'm going to have a negative value there. And now I just need one more value. So pick something over here. So let's try, I don't know, x is equal to a positive 4. And let's see what ends up happening. So now I have x is equal to a positive 4 that I'm plugging into my equation. So I have 4 plus 4, 4 plus 1, and 4 minus 3, and I get a positive 40, so that's a positive. And notice that we're looking for things that are less than or equal to 0. So when it's less than or equal to 0, then I know that I'm specifically looking for my negative intervals. So if I'm looking for my negative intervals, that's here and here. So now I can rewrite or redraw my graph. So I still have my boundary points, negative 4, negative 1, positive 3. And I know that I'm looking at negative 4, and the negative interval goes this way. I'm also looking between negative 1 and positive 3, and it's everything in between. So when I write my interval notation, it'll go from negative infinity to negative 4. That's a bracket, union, bracket, negative 1 to positive 3, bracket. And they're all brackets because it's less than or equal to. That line underneath means it's including that value. So I'm going to have brackets to represent that value. And so that ends up becoming my final answer. Now for the last one, now I have a fraction. So I have to be a bit more careful here. So dealing with a fraction, Remember, you never ever want the denominator equal to 0. Otherwise, we get an error. If you plug any fraction with a 0 denominator, you're going to get error on your calculator. For example, you can do 5 divided by 0, you get error. It doesn't exist. So what am I going to do? I'm going to have my x plus 2 over x minus 3 minus my 4 is equal to 0. I can always put it over 1 to help myself out. So for my LCD, I'll have an x minus a 3. So I will have x plus 2 over x minus 3 minus 4. And that LCD, I need it to be the same in order to add and subtract fractions. So I need to multiply the bottom by x minus 3, which means I'm going to have to multiply the numerator by x minus 3 as well. And, well, if you want to think about it, 0 times anything will just be 0. But if you want to be consistent, think of it as multiplying by an x minus 3 in the denominator and the numerator. So now I'm going to have my x plus 2 over my LCD minus 4 x minus 3 over my LCD is equal to 0 over my LCD. And that is because 0 times anything is equal to 0. So that's what I end up having. So now that my LCD is all the same, I can drop them and think about my numerator. So I have my x plus 2, and you want to be careful here. This is a negative 4 multiplied by x, so minus 4x. And a negative 4 times a negative 3 is a positive 12. And all of that is equal to 0. So now I'm going to combine like terms. I have x, and I have a negative 4x. So negative 4 plus 1 is going to give me a negative 3x. The next thing I have is positive 2 and positive 12. So 2 plus 12 gives me a positive 14. So a negative 3x is equal to a negative 14. So x is equal to 14 divided by 3. And if you want to see the decimal approximation, that's about 4.6. So now I have my let's make this a little bit bigger. There we go. So now I have found my boundary points. And I have two of them. I have my x is equal to 14 thirds, and I also have that x is equal to a positive 3. You might be wondering, well, where did I get that x is equal to positive 3? Well, it comes from my denominator. So if x minus 3 is equal to 0, x is equal to 3 is also a boundary point. So I want to be careful about that. So if I have 3, that's here, and that 14 thirds is about 4 point something. So let's just put that over here. It can be spaced out, that doesn't matter. So now I pick some values. So I don't know, let's pick x is equal to 0, and we're going to plug it into my equation. So I'm going to plug it into x plus 2 over x minus 3 minus 4. And let's see what we end up getting when we plug that into my calculator. So 0 plus 2 over 0 minus 3 minus 4, and I get a negative 14 thirds. So really, I just want to know that that's going to be a negative answer. So now the next thing I want to do is maybe pick a value over here. So a value between 3 and 4.6, so let's just say 4. That would be a nice even round number to plug in. So let's go ahead and use that. So I'm going to have a 4 plus 2 over 4 minus 3, and subtract 4, I get a positive 2. So that's a positive number that I get. Now I'm going to try the exact same thing over on this side. So I don't know, let's try maybe x is equal to 5 and see what we end up getting. So I'm going to have my fraction 5 plus 2 over 5 minus 3, all subtracted by negative 4, and I get a negative 1/2. So there is my negative value that I have here. And remember that I have my x plus 2 over x minus 3 minus 4 is greater than 0. So this tells me that I'm looking for my positive intervals. Because it is greater than 0. So anything bigger than 0 is positive. So that's here. And remember that the denominator, when it is equal to 3, because it's a fraction, this is where the fraction is undefined. So we cannot include that point. So I'm going to have my positive 3 and my 14/3. That means that positive 3, it's going to be an open circle. And at 14/3, it's going to be an open circle because it's less than or equal to. So there's my graph. Now for my interval notation, it would be from 3 to 14/3, both being parentheses around it. And that ends up becoming my final answer. And that is the end of section 10.5. So if you guys have any questions, please feel free to email me or contact the Math Success Center for tutoring. Thank you.